The second step is what I'm going to call the setup. That's step 2, and that's where I knew what I was aiming for in advance. And I'm going to have to explain to you in every instance exactly what the setup should be. That is, what the unknowns should be and what target, a simplified expression, we're aiming for. So that's the setup. And then the third step is what I'll now call cover-up, which is just a very fast way of doing what I did on this last board, which is solving for the unknown coefficients. So now let me perform it for you again over here. So it's 4x minus 1 divided by, so this is to eliminate writing here, handwriting. It makes it much faster. So this part, factoring the denominator, that was 1. That was step 1. And then step 2, again, is the setup, which is setting it up like this. All right, that's the setup. And now I claim that without writing very much, I can figure out what A and B are just by staring at this. So now what I'm going to do is I'm just going to think what I did over there, and I'm just going to do it directly. So let me show you what the method consists of visually. I'm going to cover up, that is, knock out this factor, and focus on this number here. And I'm going to plug in the thing that makes this 0, which is x equals 1. So I'm plugging in x equals 1 to this left-hand side, and what I get is 4 minus 1 divided by 1 plus 2 is equal to A. All right? Now that's the same thing I did over there. I just did it by skipping the intermediate algebra step, which is a lot of writing. So the cover-up method really amounts to the following thing. I'm thinking of multiplying this over here. It cancels this, and it gets rid of everything else. And it just leaves me with A on the right-hand side, and I have to get rid of it on this side. So in other words, by eliminating this, I am isolating A on the right-hand side. So the cover-up is that I'm covering this and getting A out of it. Similarly, I can do the same thing with B. It's focused on the value x equals minus 2, and B is what I'm getting on the right-hand side, and then I have to cover up this. All right, so if I cover up that, then what's left over with x equals minus 2 is, again, minus 8 minus 1 divided by minus 2 minus 1. All right, so this is the way the method gets carried out in practice, writing essentially the least you can. Now, when you get to several variables, it becomes just way more convenient to do this. So now let me just review when cover-up works. So this cover-up method works if Q of x has distinct linear factors and so you need two things here. It has to factor completely. The denominator has to factor completely, and the degree of the numerator has to be strictly less than the degree of the denominator.